Hello everyone, my name is Peter Schaknat. I am the proud managing director of Schaknat App, a company dedicated to advanced vehicle optimization solutions. Today we are incredibly excited to embark on a comprehensive optimization process for a Scania R450, a truly powerful and impressive vehicle that we will enhance even further. Let me briefly and clearly explain today's detailed procedure, outlining each step we will undertake to achieve optimal performance. Today we will once again meticulously flash the truck, utilizing our innovative and user-friendly new Schaknat app, which streamlines the entire process. Specifically for this Scania, we will also provide the valued customer with thorough and interactive training, again, conveniently using their smartphone, meticulously explaining the entire intricate process regarding future updates, essential maintenance, and absolutely everything else related to the optimized performance and longevity of their vehicle. The customer is Sebastian Kühnert, who has also been a long-standing customer of ours. I know him quite well, and for a long time, we have already optimized many trucks together. The customer primarily and mainly works with various types of flatbed and tipper trucks. He made it very clear to me that the truck, as a 450 horsepower version, is simply too weak in terms of performance, and he also criticized the shifting, which in turn affects fuel consumption. They frequently operate in very rugged, extremely mountainous regions where you truly and absolutely need the immense power. Today, we are once again going to optimize the engine and transmission to work together. Just a quick note about the truck itself. It is equipped with a powerful DC13 engine, which is the Euro version. The engine variant was subsequently changed again, and its year of manufacture is roughly the same as the DC13 engine. Technical changes included modifications to the turbocharger. Specifically, this one still has the standard journal bearing turbocharger, while the more new ones have ball bearing turbochargers. The engines are unfortunately a bit prone to certain issues with their turbochargers, specifically where the internal shafts tend to break on the compressor side. This particular problem has happened quite often with the AKW, as I have already mentioned, but it is a common and recognized problem if you approach it in that specific way. I always tell my valued customers, if this particular fault should unfortunately occur, if you suddenly hear a loud bang, you can calmly count 21, 22, 23, then gently turn off the ignition and just let the truck slowly coast to a complete stop. So those are really the only weak points. Well, the engine control unit and the coordinator have a few issues from time to time, but overall it's a great vehicle for tippers and walking floor trailers. The engines are very, very robust. This is an inline 6-cylinder engine with SCR only, without exhaust gas recirculation. I have to say, I have many customers whose trucks are now just shy of 1 million kilometers. And apart from the turbocharger issue, the engines have actually been very trouble-free. We will now proceed with the initial measurement, and then we'll carefully examine the resulting values together. The customer will receive both eco and power optimization here. You drive the truck yourself quite frequently from time to time, and the boss says it should, of course, pull exceptionally well before shifting gears and run smoothly overall. But in general, the main focus is truly on fuel consumption. As you know, fuel prices continue to steadily rise with no end in sight. So every single liter of fuel saved is simply important right now. We've already secured the truck, and since this is the next generation scanner, it's important for road simulation that we measure with all-wheel drive again. We're driving the front axle again using the hydraulic system, so we're synchronizing both axles. That's why, as you can see, we've secured the front again. It's always crucial that the alignment is 100% correct, because otherwise it can be dangerous at such high speeds. As you know, we have to increase the top speed again to reach 11 to measure in gear. It's just dangerous if the alignment isn't 100% correct, because then basically the car won't come out of the test bench. So up front we make sure again that it's really running straight. Then, as you can see back here, we've strapped it down again, pulling it down with 5 tons of force, using the hydraulic cylinder so that we have traction. It's always important, something we've noticed a lot, especially with tire tread and things like that. And also when temperatures keep getting hotter, you simply have the problem that the measurements of power loss aren't always 100% accurate. That's why, for example, when I'm doing development work now, I don't even have the power loss displayed anymore. Instead, I focus solely on the wheel torque, because that's where I have the least amount of tolerance. But as I said, customers always want to see the engine power, the peak power, the calculated kilowatt output. So it's always really, really important. It plays a big role how the car coasts down, that it has 100% traction there. It can even happen that if it's strapped down too tightly, It actually slips more when the rollers get hot than if I just strap it down normally with 80 bar. So these are, for example, some of the finer details. So let's walk around here a bit. As you can see, we have our tie down points and we have 10-ton ratchet straps with Dr. So double safety, so basically 20 tons. The main securing is always incredibly important for us because people have often told me, isn't it dangerous if we only secure with just 2 straps? Since we secure the hydraulic cylinder, it's really only in the very rare and unlikely case that the eyelet on the hydraulic cylinder breaks off that it truly becomes a significant issue. If a corner wants to jump forward, then the straps will briefly hold it back. Normally, I always secure it 4 times, so I have double safety, but it will never be the case that the rollers come to a complete and utter stop. So with 20 tons, that's double safety. The standard tractor unit has about 8 to 9 tons, I'd say, so that's more than sufficiently enough. And what's always much better with ratchet straps, as we've clearly noticed with chains, is that chains are far too rigid. I also have this traction problem again because of the air suspension, you see. Then let's quickly walk around once more. Here we set up the second eddy current brake. We're braking here using the eddy current brake, which then slows down the roller here. Maybe you can see that as well, so it's easier to understand. This roller here is actually the one we're measuring against. That's why it's important. If you pull too hard at the back, you're actually pulling away from the front roller, and I've already experienced measurement tolerances because of that. So, as you can see, quickly setting up the test bench isn't really how it works. You really have to think carefully about securing everything properly, because otherwise you'll end up with incorrect values. As you know, our test bench can measure up to 1,800 horsepower and 5,500 Newton meters. Well, we're certainly not going to get that kind of performance out of a 6-cylinder engine, or we're not going to come anywhere close to it. The trucks have, as a standard feature, 2,300 Newton meters of torque. Now let's see precisely where we end up with the initial measurement. On average, it's the same as always. We consistently try to aim for these 300 Newton meters. If someone genuinely wants more power, we can go towards 400 Newton meters. But to protect the engines and ensure their long-term longevity, we really have to be careful. There are also different types of transmissions available, but you can always read that information out based on the specific transmission model. For example, if you happen to have a weaker transmission, you absolutely have to be careful and not overdo it with the torque, so you don't inadvertently break anything in the drivetrain. The engine itself is usually less of a problem for me. It's typically the transmissions or the rear axles that cause issues. But then again, Scania has one of the most robust and durable drivetrains in the industry, so knock on wood. I really have to say, we basically never have any significant issues with damage or anything like that. That's precisely why we checked. Last year we had over 1,000 Scanias from all over Europe come through our workshop. Done. And as for the complaint rate, of course, there can always be cases where someone says the power isn't enough, they want a bit more, or the fuel consumption isn't quite right. You can always make adjustments there, but as for anything actually breaking because of this, knock on wood, really, not at all. Let's walk around it once. You can see it from the front. The truck is from either 2017 or 2018, I think. Beautifully and meticulously done. I truly think it's really, really cool. The paint job, which is absolutely stunning, is also set off incredibly nicely with the sleek black accents. I genuinely think it turned out really, really exceptionally well. It's a very, very impressive truck, you really truly have to say. I've said before, red isn't exactly my personal favorite color, but in this particular combination, I think it looks absolutely awesome. I really, truly like it a lot. Scania trucks already possess a very nice fundamental basic shape, so you can create a truly stylish and distinctive vehicle out of them pretty quickly and efficiently. Sure, you can certainly make something good and appealing out of any truck, but you can clearly see that with these specific models, the absolute most is always done and achieved. And as I said earlier, I'm really looking forward to the initial measurement now. Let's see precisely what kind of impressive power it puts out in the baseline test. We've now successfully done the initial measurement, and it was really truly spot on. An absolutely brutal and incredibly powerful baseline performance. It's officially supposed to have 450 horsepower stock, 2,300 Newton meters stock, and this magnificent truck has almost kilometers on it. So now let's take a very close look at the baseline power output. A valued customer mentioned last time that he would be very interested if we explained the intricate torque curves in much more detail so that we can explain them even better and more comprehensively. So As I previously mentioned, I have specifically grabbed a meter stick to thoroughly explain this concept to you. You can clearly see up here, to illustrate it even more effectively, this distinct lower curve here. This is indeed the crucial torque curve, and that's precisely what truly matters to us when we are driving on the road. The upper curve here, this is the power output in kilowatts, which is then converted to horsepower. I can very accurately calculate that, and the power is determined via the rolling resistance. But for us, that's actually completely irrelevant, because where the actual power in kilowatts is precisely measured, that's typically at a very high RPM. Just to clearly show it again, if you carefully look here, this prominent blue line going steadily up, that's the absolute peak power. That's precisely where it ultimately reaches 448.4 horsepower, but you can clearly see it down here when compared to the torque, just so you can fully appreciate the direct comparison. Here we have 1900 revolutions per minute, so you basically never drive at that speed, but that's where the truck measures its peak power, and that's why I always say, because people always ask about the horsepower, it's actually completely irrelevant. What's important for us are the lower RPM ranges. That's where I can save fuel. For example, I can program the truck, you have 300 or 400 Newton meters more torque at the lower end, and for peak power, stock settings, running stock from 1600 or 1700 RPM, it has 450 horsepower, 300 Newton meters more torque. But of course, people always ask for more power so that you can pull it out longer at higher revs, and that's why the kilowatt output is calculated, just to give you an idea. Now let's take another look at the torque curve, because that's what's important for us. So as you can see down here, we have 1000 RPM, 1200, 1400, 1600, 1800, 2000, and 2200. It rises here, reaches its maximum torque at around 1100, but only holds it for a relatively short time until 1300. You can see the axis here when you get to 1300, and then it drops off sharply. So you actually only have a short torque band. Over here you can see the torque axis from above. So you see it's about 2 or 3 over here. So you can see the maximum here. And on the left going up, you can see the horsepower output. And up here, you can basically see this peak performance as well. And that's what's truly crucial and absolutely essential now. Our primary and most important focus is always right here at this very point. Now we're going to try to get the torque to come in earlier and stay high for longer, so that it holds here for a long time and doesn't drop off so sharply, but instead stays up here longer. And of course, as a result, it then has a significantly higher peak output. But that's not our intention with the optimization. The intention behind the optimization is clearly to increase the torque at the lower end. The advantage of this is that if I have more torque down low, I can shift into higher gears earlier, which means I have far fewer gear changes because it pulls better at low revs. Or, for example, when I'm driving up a hill, it pulls me down. And at some point, the truck finds its steady point where it holds, and as a result, you save fuel, you have fewer gear changes, you have lower RPMs, and that's exactly the area where we want to make improvements. And the 13-liter engine is also available up to the S model. In that series, the engine is called the DC13, and in the new Euro D standard, there is one with 540 horsepower. However, the engine in the DC1048, which we have now, is structurally a bit different from the one in the S model. But as I said, it's still a basic inline 6-cylinder with individual cylinder heads and all the usual features. So I would say if you were to tilt the engines up, you would hardly notice the difference between the original 500 horsepower and 450 horsepower versions. All right, let's get started now. We're going to program with the app now, so let's get to it. First, we'll flash the eco optimization, or maybe I'll talk to my customer again, and perhaps we'll flash a small power optimization. You'll see it in a moment. We'll do the unlock again, then flash right over it, and then we'll immediately do the baseline measurement again. We're flashing again now using our Schaknat app. Here you can see the dongle again, just as usual. For 24 volts and an iPhone or iPad with iOS 15 is a basic requirement, as he already mentioned. A lot of people always ask me what exactly do I need in terms of an iPhone. So once again, the basic requirement is iOS 15 from iPhone 8 onwards. I always tell people you can actually already get one on eBay for 50 euros, which is perfectly sufficient for our purposes. So starting from iPhone 8, we definitely have iOS 15. Now we're connecting again. As you can see down here, this is the OBD connector. You can see here again, the light is blue, which means it's searching for Bluetooth. Now I go back into the app, basically open the Schaknat app, go here to the Schaknat app, and then select Scania again. So Very important, always turn on the ignition first. Now, I will proceed here to the adapter settings, specifically Bluetooth, and then diligently look for my particular dongle. As you can clearly see, I already have several devices saved. This specific one down here, you can observe, is currently connected to the Reiseverhalten. Now we go back to the Schaknat app, and now it should actually already be detecting the vehicle. So then I also enter the vehicle. That's always very important for us, because just like online, you can see which vehicle it is. That way we can access the customer databases more quickly. So I always ask people to please enter this information accurately, including the license plate, vehicle, and also the customer's name. Now we go back to the engine control unit, and as you can see here, the customer can again read and clear the error memory, reset to factory settings, ECO, and the power optimization. I've just discussed it, and I actually want the higher performance. So now we're going to flash the power optimization again. Then we'll take a look at the output performance. Now we're going to do the power optimization again. Now the progress bar starts running, and with the scanner, it goes super fast indeed. As I said, in about a minute, you should briefly hear the fuel pump running in the background. That's precisely where these CAN bus errors originate from. That's exactly why we've included the error memory, because all the control units that want to communicate with the engine control unit now basically receive an error message. So that's a CAN bus error, a communication error. But we can simply clear that, and then the error memory is 100% completely clean again. 84%, I can really say the EMD or S control units, especially the Euro 6 models, they really work great, performing exceptionally well. Now you heard it, click, click. That means it's finished programming. The process is complete. Then we click OK here, and it jumps back to the main screen. At this point, we can actually read and clear the errors right away, without any delay. You see the errors here again briefly, the CAN errors, the communication errors. Error memory reset, done. The error memory is completely clean again, absolutely spotless. Let's go back one step. We've now optimized the engine, and now we proceed to the transmission control, specifically the TMS. Here you can also read and clear the error memory separately for the transmission system. Now we go to optimize the transmission itself. It's relatively quick, did you hear it? The transmission clicks again, indicating completion. We click OK here again. So the corner is actually already fully optimized, both the engine and the transmission. As with the error memory in the transmission, you also get CAN bus errors in the transmission, which are quite common. We clear those again, and the error memory is clean again, completely clear. Now we move on to the output measurement, the final performance check. We're going to do the output measurement again on the dyno, the dynamometer. It's very important to always turn off all distance sensors, everything, and also turn off traction control, because on the dyno, with the wheel speeds, you don't want anything to be detected incorrectly. And with the hydraulics, since sometimes the corner is slower or faster, you want to make sure the synchronization works perfectly and accurately. So now we'll start slowly with careful preparation. It's always important to warm up the tires, as I mentioned before, but not too warm, just adequately. You can see it with these hot temperatures. Today is really a brutally hot day. It's already 33 degrees Celsius. You also shouldn't do too many measurements in a row, because that significantly affects measurement accuracy and consistency. We do have a fan in front, everything is on, but with 33 degrees outside temperature, I can see on the test bench we have two. So the input power for the temperature is already amazing, quite impressive. The test bench calculates it according to ISO 70020, always a bit lighter, but it's always better to have, I'd say, 15 to 20 degrees for the measurement. That's the ideal range. That's always better for optimal results. So fan on for cooling, then we go again, ready for the next step. I've done a speed synchronization at 1000 RPM, a precise calibration. Now we brake again from 800 to 2200, so we can really measure the maximum power cleanly from bottom to top across the entire range. That's why we also specify the top speed for comprehensive data. So now we brake at 800 RPM, close the eddy current brake. Now we're braking it, applying the resistance. Now my turbocharger is whistling, but very quietly, a subtle sound. Now we start the measurement, initiating the data collection. Now I go full throttle, maximizing the engine's output. You can also see how smoothly it runs here on the test bench with remarkable stability. And then we disengage, releasing the power. When disengaging, I always let the gear pull through again, so I don't take the transmission with me at the top, ensuring the drag power is calculated correctly when disengaging for accurate results. So as you can see here, we can take a look at the front. Brutal output power, that's the power optimization in action. You can see we now have 550.6 HP and almost 2,800 Newton meters. That's 2,788. So that's almost 500 Newton meters more, a significant increase. Yes, almost 500 Newton meters more torque, a truly impressive gain. Clearly that's an excellent output. And also look at the test bench at 30.8 degrees. That's really insane considering the conditions. So to balance things out, we always do 3 input and 3 output measurements just to rule out test bench tolerances. So we really have 100% accurate measured values, ensuring reliability. Because you can see if you disengage at the top and let off the gas too early, the lost power isn't always calculated 100% correctly, leading to inaccuracies. That's why it's always important. I always do 3 input and 3 output measurements to really have a 100% accurate value, a truly precise figure. If all 3 measurements are the same, even better, indicating perfect consistency. The test bench, I have to say, if you clamp it down properly, it really measures 100% accurately with incredible precision. It's always amazing that you can calculate it so precisely, because you're actually only measuring the rear axle and then extrapolating to the engine power, a complex calculation. And you can see the values are really fantastic. They're really pretty much spot on with the stock figures, showing excellent correlation. Well then, I would say I'll take a measurement of the output now. We'll see you again at the monitor. I'll briefly explain to you the output power, what we're doing with the gearbox tuning, what we're going to finish here at the end. Then we'll see you again at the monitor. We've now taken the output measurement. Let's take a quick look at the curves. As I said, this is Sebastian Kunnert. He's the boss of the Kunnert company. Also, how you drive the truck yourself. As I said, Sebastian, I'll briefly explain the curve to you now, or to the customers, so that you can see the whole thing. You can see here again, we've now flashed the power optimization. You can see the lower curve here again, the blue one. This is the input torque, and the upper curve you can see now is the output torque. So you can clearly see that it drops off here at the back. You can see it too. We now have the peak power here when we go back up again. It's much earlier now. So we have the peak power now at around 17 kilometers per hour, roughly 50 kilometers per hour. Now, very briefly, to explain the torque again, that's what people always want to know. Or for you too, Sebastian, you can see that your maximum torque is actually already at 150, 900 revolutions. So that's it. And then increases at 1000. You now have the maximum. And we now have a peak power and a peak torque of 2,780 and 550 horsepower. And you can see that's compared to 2,306 Newton. That's almost 500 Newton meters of torque, I always say, with the 13-liter engines. My rule of thumb, I've always said I have 580 horsepower and 2,850 Newton meters of torque. We've gone down slightly now. In terms of peak power, I would say that's still a really healthy mix. You can see that the engine at the boiling point has a completely different torque at the bottom than it is now, more willing. In terms of acceleration, we also optimize the transmission with the app. Things like when maneuvering, when you shift forwards or backwards in construction zones, that the gears engage easily so that it pulsates. You have less wear and tear on the gearbox. Synchronization is also important so that it lasts as long as possible. Because I say the module use is simply a heavier application, like long distance haulage all day long. And as I said, you can see here, again, very briefly, towards the top speed, we are running in series again. So if I were to do that, if I said you really want to have the horsepower, then I would simply leave the curve here longer. Then at some point you would have 600 horsepower up here. But as I said, it is completely irrelevant. The low-end torque is crucial because I have already said that you can increase the gear ratio much earlier or you can increase it much earlier. Yeah, you already have more at the bottom. The maximum torque is already there earlier. It is a very simple formula. What I always say, every revolution needs a fill. Low speed means low fuel consumption. So we always try to get into the high gears as quickly as possible so that it then has the torque and that saves fuel. You know that yourself, when you hit a difficult hill, heavily loaded, and you can move up a gear with less revs, you save speed, you save a rev, and therefore fuel consumption in the gearbox, because then there isn't as much forward and backward shifting. So that's the whole point of everything, which you already know from the other optimizations, but I'll just explain it again on the test bench. Also the customer number, you can see the torque is enormous. That's almost 500 Newton meters. More torque from here to here, almost 500 Newton meters. You'll definitely notice that in terms of driving, it's a completely different engine. Of course, the main thing is always important. We want to destroy the engines, but because it's a 13-liter engine, we have some room for improvement. The engine would be even better because we can get all the power from here to here. Loosen up, we've done a lot with the setting already and have never really had any problems. The customers have actually always been extremely satisfied because, yes, Sebastian said to you, I'll give you the app I showed you from Flash It Here. You now have the option yourself. It's still included with the dongle. You can show it again very briefly. There will be a QR code. Everything will be added, and that's explained. You can now use the dongle. In principle, the eco, the power optimization, as we discussed, you can program it back and forth individually. It could be, if you say the driver is there's a driver who maybe doesn't pay as much attention to the fuel consumption, then you can flash the eco optimization. The eco optimization has about 150 Newton meters less torque, so you can decide for yourself. And the good thing is, when you go to the workshop, it always does a software update on the go, or what the app can do. You can reprogram E yourself, because the app is so intelligent and recognizes the update standard. And what is important is that it really reads and deletes the error memory. So as I said, I think you'll have a lot of fun with it, the app, please. But as I said, what every customer gets from us, because we have optimized our Hugo Boss air freshener so that the Oro smells good. Well, Sebastian, as I said, I was very pleased that you personally, there you were with the car, really typed, I did it, I really like it. As I said, it's a standard car, in quotes 450, but you can see for yourself, if you do a bit of visual work and also optimize the engine and transmission, you can still make it great. I was pleased, thank you. See you next time. Thank you, ciao, ciao. We're back at the end of our video. If you're interested in this topic with fuel savings in trucks, please take a look at our website, www.schknat.de. It has the right contact person in the area of fuel savings in trucks. I think we have the right contact person. We have already helped a lot of customers. If you'd like, feel free to write an email, call us, send a WhatsApp. We are happy to advise you on the phone on this topic. You can see the savings you might have in the fleet when it comes to long distance or local transport. You can always narrow it down a bit, and you can also have the ambulation time calculated for us, because I would say with the fuel savings that we will have here, I think in the topography application, because I know from the type of customer where we, as we've already spoken about today, I would say if we actually save between 3 and 4 liters, and that happens very quickly, with the mileage after 2 to 3 months, I'm always pleased that you subscribe to our YouTube channel so diligently. Feel free to write in the posts what you'd like to see more often. Thank you for watching. See you next time. Thanks. Ciao.